People in this class, the other class, they missed that mistake is torque. I mean, you have this two torque on the system, and obviously the toe torque must be equal and opposite. I mean, this is very basic static. You cannot make a mistake. I had one student in other class who couldn't start the problem because they don't know what to do about it. It's such a simple case of a static that I'm surprised that some of you made mistake because in the sign system, because these two have to be equal and opposite. So if there is a torque going this way, the other torque must be going the other way. It's obvious. It is so simple. You have seen it in all. This cannot be any simpler than that in ME 218. This has nothing to do with the beam action yet. Therefore, you solve this system and you get your force to be equal to 430 pounds. So that is the force F1 and F2 together make this torque and that torque. Anyhow, that should not be any problem for anybody. Then you have to go to the beam action. Now, beam action, many of you draw that, but it was either plus or minus. I didn't subtract point for that one, although you have to do it correctly because you have to understand. If you want to answer the last part correctly, part B, you need to exactly to know which way the beam is bending. This is the beam action, so please be careful. This is the right direction, although I did not subtract point because I'm assuming you knew that everything is going to be square, so therefore minus does not make any difference whether it's plus or minus, so based on that I gave you credit. However, what I do not want to know that at this time, many of you, but to me, that few, even if it is 5 people or 7 people, is too many. Because you cannot sit in this class and do not tell me you don't know how to draw a beam, a simple beam with one load on it. I mean, that's a no-no. That's something that I have given you, or we have given you so many beam with the loading system in ME 218 and 219 to draw and shear and moment diagram, and you can tell me that this is the beam and you cannot draw the moment diagram for this simple beam. This is very surprising. Everybody understand what I'm saying, that the direction of the load doesn't matter. If you have done any of your homework, there were many mistakes here. I'm repeating those mistakes for the future. I don't want you to go through this without realizing what kind of mistake you are making, which looks a little bit difficult to even comprehend why you are doing that. Anyhow, so this is your system, which is in the XY coordinate system. So this is in the XY plane. And then you have a beam that's sitting on a bearing or support. Doesn't make any difference because this bearing acts like a pin because they only carry forces. And then you have here a load of, let's say, 470 pounds. Notice I warned you about that. I said when you're taking torque, you subtract this from each other. When you finding the force, you have to add it because the forces are in the same direction. You cannot, again, about 20% of the class. 30% of the class or more, 40% of the class, they mistaken the diameter and the radius, which still is okay. I did not subtract too many points of that because the radius is different from the diameter, but you got twice as much torque, but the procedure was correct. Then we come to the beam action. Many of you did it correctly, but a few of you cannot do that, which is a little bit strange because you can't calculate this reaction. This is force upward. Usually they are downward. So the reaction will be downward. So you have 147 here, and then you have here 323 here for the total of 470. You go by the ratio of, I believe, 33 inches by 15 inches because total here was 21 and 12, this one. But however, be careful. This is point A, this is point B, this is point C, and this is point O. Is that correct or not? Now, what's the big deal that at least 4, 5, 6 people stop there not drawing the? You don't need to do even shear diagram. Who asked you to do the shear moment? All you need is your moment diagram. Is that correct? I don't know why you are even attempting to do the shear moment diagram, but this is what I don't understand. going through ME218, going through ME219, at least 10 people, when they wanted to calculate the moment at that point, they said 470 times 33. That's external moment. Yes, the moment of this 470 about 0.0 is 470 force time distance, but who cares about that one? We are talking about internal moment in the beam, yes or no, correct or not? That internal moment has totally different property or system, has nothing to do with this one. Many people make mistake there. That's surprising. The moment you have to cut the beam, you look at the left-hand side or the right-hand side, including, otherwise, why are you calculating? If you want to put moment at this point, they did it like that. Moment at that point, 470 times 33, and put it there. I mean, how can you do that? Everybody understand that? That's a no-no. Because if you are doing that, why did you calculate the reaction after all? Everybody understand what I'm saying that, yes? Anyhow, making the story short, the moment at that point is 147 times 33, yes or no? As you have seen it in all your homework, yes, correct or not? So therefore, anyhow, the moment diagram for this one, by the way, which is, when you look at it, is about mz, because this is in x, y plane, and at the moment is perpendicular to that one, which is mz, and correct way of doing it become like this. So this is point B, this is point A. At point B, you get 4,000, and many of you, of course, get it correctly. On average, I'm a little bit encouraged because your average is higher, and I had at least 4 or 5, 6, 20s, 100%. In one case, somebody got 21. I explained that why. So at the end. Anyhow, so one bonus point. And I tell you what, this is the moment diagram for this beam. Is that correct or not? You are pulling it upward. Therefore, tension will be what? If you're pulling it upward like this. So this is all has been discussed before. If you're pulling it like that, tension is on the bottom, compression is on, I'm sorry, tension is on the top, compression is on the bottom, therefore it should be negative. But nevertheless, some of you draw it that way. I give you credit because, as I said, minus square become plus, yes or no? But to answer the last part of a question, you need to do it like that. So that is this one. Then you go to the other one. The other one, it is on horizontal plane. You can turn it around and make it in the XZ plane. As you see, the loading in the XZ plane. Therefore, the bending is about the y-axis. Is that correct or not? The perpendicular axis to this one, because this is cross product. This cross product, this is basic static. Nevertheless, again, this is point O, this is point A, this is point B, this is point C, and then the loading system at A we had now 680 pounds, because 600 plus 80, 680 pounds. Therefore, you put it there, and then the same way when you draw the moment diagram, this moment diagram become like that. At C is 0. Again, this is the one particularly I was very interested. Many people wrote the moment at this point, 680 times 12. Again, absolutely wrong. Is that correct or not? That is RA times 12. Is that correct? This is internal versus external. Is that correct or not? Therefore, that is a no-no. That means you have to go back again and please that. This one is MY. This one is MC. Some of you did not commit. Some of you did it right. Some of you were in the wrong direction. Again, did not subtract point for that one. I pointed out to you that's not correct. That what is important here is this is point A and this is point B. This is MY. This is MC. Now, at this point, you have to put it in that equation I gave you. The equation is there. Is that correct or not? Now, here is when things goes wrong that I do not understand. I gave you 4, 5 homework. Yes or no? Most of them were double bending. Yes or no? Except one of them. All of them were double bending. Was it that? Yes. Most of them were double bending. And you come to this point, and the student only take this. This one becomes 6,000. Few students only took this, as if this doesn't exist. They saw this is larger than this one, so I'm putting this in that equation. They haven't done any of the homework. Is that correct or not? Everybody getting the point? If you do that, you are going to lose the whole point. That's not the case. Everybody knows that. Yes or no? You have two action. You have two bending. That was the whole discussion. You have a bending like that. You have a bending like that. Therefore, you have to consider both of them. Then comes the second mistake. Okay, that is very bad mistake. Everybody understand that. That's why I put a 3 question mark in your quiz. That means you made it very bad mistake that it should not be there. Look how many red marks like that. 1 mistake is okay. 1 question is okay. 2 question is bad. 3 question, forget about it. Is that okay from now on? You know how I'm translating the information to you. Nevertheless, what is important here? Now, coming to the second mistake. Many people put this because they knew it is 2 of them, but they took this square plus that square. Is that correct? No, absolutely not. This is at point B. This is at point A. Everybody understand what I'm saying? That by drawing that correctly, by doing one of your homework, you would have immediately recognized what you are doing that. You give me a bunch of homework, I give you a bunch of 20s. Everybody understand what I'm saying that. But is the value there? I don't know. That's for you to make a judgment there. So what I'm saying that when I give you this homework, every one of this homework has a point into it. You don't have to do all of them, that's fine. But do one of them and do it correctly. Get out of the system is the same. See, you understand that. If I give you an indeterminate problem, the people did it in the other class after 5 minutes. Few people left it, and they act like this is determinate problem. They found from a static, they found 5 of them at the beginning of the class. They were so happy leaving, but when I give them back their quiz, they will be crying. Is that correct or not? Because they solve it as a determinate problem. I told you that they are going all to get Nobel Prize, yes or no? Yes, because they solve an indeterminate problem with a static alone. That means they found a reaction. So the whole system collapses. Is that correct or not? Yes? So remember that. What I'm saying that if each problem I give you, there are certain ideas that has to be settled with you. And that idea comes with practice, practice, practice. Anyhow, so the moment here is the moment at A is this much. The moment at MZ is we have this much MZ and we have this much MY. Yes or no? Correct? That was in every of your homework assignment. Correct? So therefore, you have to calculate that. Of course, you can make mistake now there. That is okay for example, because the ratio here, this was, I believe, 21 inch and this was 12 inch. You have to divide that in that ratio, similar triangle. Nevertheless, this becomes 1,764 pound inch. And the other one become equal to this one, become 2,055, I believe, pound. These are all in pound inch. So if you put the unit here, so you don't have to repeat the unit. Is that correct or not? Now is that the same next question. Which one of this point is going to be the most critical point? Is that correct? That's where you're designing for. The design goes always to the most critical point. If I make that point safe, then every other part of a shaft is safe. So where is that? As you see, from O to A, I'm explaining this for you guys, for those of you who didn't do proper job here, at least for future, you know what you are doing. Is that correct or not? This is part of assume part of a lecture. So I spent a little bit more time explaining this to you. So from O to A, there is no torque. So most likely there is nothing happening there. There is some bending there, but the most critical point will be between A to BB, from right of the A to the left of the B. Remember that. Actually, the answer is, some of you said A or B. That's not correct. So you have to go to the right of A or left of B to find out where that system is going to break. But then the rest of it depends on your moment here. Everybody see that. So since torque is constant, in one of or two of your homework, torque was not constant, so you have to consider all 3 of them. T is mx, my, and mz. Here, torque is constant, so all you have to do, check your moment. So this is all you have to do. Look here, you say ma, because this is a vector operation. You have a vector going that way, you have a vector going that way. You cannot add it together directly. You have to square it. Is that correct or not? So that's what we did, and that was the equation was all about. So this one gets from 1, it gets 1,700, how much was it? 64 square. From the other, this is mz square. then you get my squared, which is 6,120 squared. For mb, some of you went all the way, check the diameter. That's not necessary. You check this, and then you pick up the one that's most critical. Everybody understands, but that procedure is correct. Then for the second one, you get at B, you have 4,847 square, because this is vector, so, and plus my become 2,550 square, and then whichever is the largest, you pick up that one. And it happened to be at A. Everybody understand that. But you have to show that to me, that whether A is larger or B is larger. Everybody understood that, yes or no? Then after that, if A is the, then will be on the right of A. So this will be the most critically stressed point. So I'm checking my now design. Then I'll say J over C equal to square root of. So you can put that answer down here, or you can rewrite it again. 1764 square plus 6,120 square plus 2,340 square divided by 8,000. You solve J is equal to pi over 2, C to the power of 3. You calculate the C. C ends up to be 0.814 inch, or D become equal to 1.63 inches, larger than 1.5 inch. Therefore, it's not safe. Is that correct? Because it should be larger than what is given. Correct? Any of this is missing. Then come to the next question. So if you miss this part, obviously you cannot answer part B, yes or no, because part B is related to this. Part B is where is the most critically stressed. So many of you said A. You should have said it. Again, I did not subtract point. Right of A. But that's not the exact question that I'm asking you. Please, everybody, read the question. What did I ask you to do? Only one person in this class answered me correctly. In the two classes, even 3 people all together, because I give this time the same question for both classes to see what I'm asking you is balanced or not. I usually do that once in a while. Usually I don't give the same quiz for 2 classes. I do that to see, because one class, the average is a little bit lower than the other class. I just want to see whether I'm asking difficult question from them or it's their sort of relative strength compared to the other class. I did do that for my own knowledge, everybody to understand what's going on. Yes? And I see one class is lower average than the other class. That's what I do. But fortunately, in this case, both of you average of the class was exactly the same. So within a few points. That means everything should be OK. Is that correct or not? However, you cannot make certain mistake. At this level of a strength of material, you cannot make a static mistake, remember, like the question number 1. You cannot not draw a shear and a moment diagram for this kind of beam. Is that understood? Yes or no? We are way beyond that. Nevertheless, this was the answer. So now the last question is this. Now, I ask you not even, of course, A is already part of a deal. I am not going to ask you that question again. Look what I asked you. Not even where it is in the length of the beam, where it is on the cross-section of the shaft. Yes or no? So in other words, if this is the shaft, and is its compression here, is here or there? Everybody understand that. But you have to realize that this beam, look at the picture. This beam, you are pulling, this is the shaft. You are pulling it in from your side. You are pulling it toward you. Therefore, it's going to bend like that. Yes or no? So this side is compression. This side is tension. Yes or no? I'm sorry. The other way. This side is tension. This side is compression. The other one, you are pulling it upward like that. So this side is tension. This side is compression. If you put that in the vector form, which one person did, so you get there, you get the mz going like that, and then you do the my going like that. This is your my, this is your mz, this is your mz, this is your my, and this value is 1,764 at point A, or right of A, is not this and that. It's 1,764 mz. And how much my you have? You have my is 6,120. 20, that is 6,120. So the vector resultant of that is this one. Is that correct or not? So if you put your hand there, this is a static again. Look, everybody, put your hand there. Here is the compression. Here will be the tension. So the compression is here, the tension is there. And if you want to find out that angle, what that angle is, of course, you have to go through this operation, the value of this over that. You calculate this. Apparently, that angle becomes 16 point, no, this angle, which one is smaller? This one is smaller, this one is larger. So therefore, this angle becomes 16.1 degree. Tangent of 1740 over 612, that gives you exact location of the crack. So what do you need that at? In case you want to put, next week we are going to go through strain gauges. How do we measure the strain and how we check something you built, you design, you want to check it. How do you going to check that? You put the gauges there. Is that correct? That the gauges, you want to know where to put the gauges, that's where you put the gauge. Is that because that's the most critical point, stress point? Is that correct or not? And then we'll go through that process. But you have to, guys, you have to do a little bit better job than that. Is that correct or not? On average, the average was higher, as I said. But still, there are points that I see there which I do not like to see. Is that correct or not? Yes? All right. Any question? Any question? Now let's move on. So what is important here is your homework now. Now remember again, this is what I said. Yeah, every homework that I give you, it has some point on it. Unfortunately, I don't know how do I can sort of read your result. You give me lots of homework, but if you are not showing it in the quiz, I will worry about it a little bit. Look, I have this time purposely, I am giving you less problem from the book, which has the solution are available, more problem from the handout, for you to work on it. If you don't want to do all of them, do one of them. Anyhow, these two sets are for singularity method. So the next method is singularity method. And after that will be superposition. When we finish this, then we are going to have a quiz. If that will be next Tuesday, I will let you know if I can finish this subject by end of this week. So we will have our quiz next Tuesday. If not, then we'll have it next Thursday. I'll let you know on Thursday. Is that understood? However, you need to do at least one or two problem from this set, one or two or three problem from that set. If you don't have time to do all of them, don't worry about it. Do one or two, but do it correctly. It makes sense? That way you set up yourself for the understanding of what is going on. So you cannot, one thing that you cannot do is do not recognize indeterminate problem versus the determinate. That is a big deal there because, as I said, I gave them an indeterminate problem, and the first 4 or 5 written that I saw, all of them solved it as a determinate problem. That's a no-no. I don't know even when it's coming from. You have more unknown than the number of the equation of equilibrium. You cannot solve it. That's one idea. The second idea, which takes us to the new method, was this. Anytime a new load comes to the system, I have to break the beam into parts. Yes or no? Everybody understand? This is very important to understand why we're going through this system, the new system. Okay, this was the problem. Let's put this one now in perspective. Here is the problem. And if I have a load here, a load there, a load here, MO, P2, P1, and a load here, and let's say somebody comes and tells me this is point A, this is point B, this is point C, and D, E. Notice E is fixed support. First of all, is this a determinant problem or is it indeterminate problem? This is determinant problem. Is the one fixed support should be enough? Is that correct or not? I have two unknown there because EX is 0. I have EY and I have a moment there. Everybody under the people there, they forgot about the moment. Why? They have gone through a static. How can you forget about the moment in a fixed support? I have no clue. Everybody understand that. So in other words, what I'm saying that this is what I gave them. I gave them this. This was a fixed support here and a load here. This was 2 and the 2. This was 16. 5 people write this reaction is equal to 8 and that reaction is equal to 8. So I don't have to do any of this. jazz. Yes? Everybody see what I'm talking about? I mean, if the reaction, you find a reaction, so the system is solved, or it's done. Is that correct or not? Yes? This is fixed support. This is a pin support, correct or not? This cannot be the same. You have two reactions here, one reaction here. Is three, is one too many. You cannot solve this unless you go through one of these systems, either singularity method, superposition method, double integration method, the other method. Everybody understand that. What we said before is this. So let's summary that before we get to that. We went through double integration. Yes or no? Double integration. Let's summarize that. If this summary makes you feel good about your homework and not make a type of mistake that people make in the quiz. Yes or no? That means you write EI d2y over dx squared equal to m as a function of x. Then the next equation will be theta equation. The next equation will be the y equation. This is obvious. You have done it many times in your quiz. I'm saying that because I don't want that mistake there. Therefore, the only boundary condition that you can use is theta boundary condition and the y condition. However, another alternative was, as you did it in this problem, remember that problem? When the load is continuous problem and it is not simple because it is a function, finding m is very difficult. Is that correct or not? Because m requires integration itself. So why not try to do the same problem with the direct method? That's what I gave you the homework. I'm summarizing it because many of you do not ask me those questions. You just assuming when you submit your homework means you have done it properly. Everybody, and then I give you a quiz and I don't see the result, then I get nervous. Everybody understand what happened there. Okay, you did that. Regardless whether it is determinate or indeterminate. If I put a simple support here, this will become determinate. If I change one of them to fixed support, the other one, it becomes indeterminate, become worse. Everybody, and because I cannot find even the reaction. Nevertheless, doing that, you write EI d4y over dx4 as a w as a function of x. So the first integration I don't have will be what? Will be the shear function. The second, this is the summary of what we said last time. The second integration will be the m, and the third will be the theta, and the fourth will be y. So you have C1, C2, C3, and C4. So there is more unknown is involved. It is longer. But then you don't have to worry about writing the equation of m as a function of x because it was not possible to write it. Is that correct or not? Now, what happened here through the operation, if I want to calculate theta here, theta there, or y there, I have to get rid of C1 to C4 from the boundary condition. Now, what happened next is this. I have given, please, everybody, look at your handout. Go to page 2 of your handout. Everybody, go to page 2 of your previous handout, not the new handout, the handout that you have. You see all the boundary condition is given to you. I don't have it here to put it on the screen. I don't have it with me, but you can see it there. Everybody go to page 2. You have it on your, yeah, that's good. This one. Thank you. This page. Everybody see what I'm talking about? Yes? Notice these are the typical of the connection or of the support that you may have. The first column is theta and y condition. Everybody see that? Mm-hmm. Which applies to this only. Because this is, you have theta and y. But this one, if you have a C1 here, a C2 here, this you can have to use shear and moment, which is the right-hand side. Look at the right-hand side. All the condition is given. Usually one is 0, the other one is not 0. This is very interesting. They are all related to each other. Theta and m are related to each other. Y and RA is related to each other. This is all coming from static, which I was teaching this morning to the class, by the way. When you restrict a motion, you create a reaction. That's the boundary condition by itself. Everybody understand now what I'm saying? That if the beam is going down, if the beam is like there is free to go down, there is no reaction there, yes or no? Therefore, it goes wherever it wants to go. Yeah. As soon as you put a support there, you are restricting the motion, but it gives you a boundary condition, yes or no? That's why we are able to solve all the indeterminate problem as well as determinate problem by going through this deformation technique. We call it deformation method in general. Is that correct or not? You need to go through this deformation to solve static of the problem. This one doesn't need anything. This is determinate. Everybody understand that. But in this problem, if I've changed this from, as it was in your homework, as I changed that to a fixed support, not even I have to use direct method. I have to use the technique first to calculate RA and RB and MB. Everybody understand what I'm saying? That this RA is unknown. This RB is unknown. This M, which some people forget about it, is also unknown. You have too many unknown. You have only two equations of equilibrium. Sigma fx does not help you because sigma fx 0 equal to 0. Everybody understand what I'm saying? I have done that. I'm repeating because I'm wondering what the people are doing in the quiz. Everybody understand what I'm saying? That is that correct or not? Therefore, not even you have C1, C2, C3, C4. That's 4 unknown. Then you have RA, RB, and MB to worry about. Everybody, and so you have 7 unknown there to solve it. Is that correct or not? By setting all your boundary condition at this point, shear equal to RA, yes or no? At this point, M equal to 0. Then you have Y equal to 0, Y equal to 0, theta equal to 0. That's 5. You have 2 equations of equilibrium. That's 7. That solved it for you. Is that understood? Yes? Is that what you did? Is that what you did, understood from your homework? Yes or no? No. That is what I'm talking about. Everybody see what I'm talking about. Well, it is determinate. If this is not there, this is a simply supported beam. I can find a reaction. I don't need to do any of this. Everybody understand that? This is a determinate problem. 3 or 4 of your homework were indeterminate. That's right. So that's beside. Now, we have another problem as well. Look how many unknown was there. 1, 2, 3. If this was fixed, 1, 2, 3, plus 4 of them, 7 unknown. This is lots of unknown, and it becomes impractical for me to give you that problem. Yes or no? But that problem already is a determinate problem. Yes or no? Yes. However, if I put here another support here, if I soon, I'm not going to do that. This also becomes indeterminate problem. Everybody understands that static is not going to help you. Is that correct or not? So you have to go through this. Now, let's look at that one. Let's say it is determinate. Forget about indeterminate first. So forget about indeterminate problem. That problem, because it does not have any support here, therefore it is, if I give you this 10, 25, or whatever, you can find the reaction. Yes or no? Correct? It's determinate. Now the problem is this. How many times should I cut this? Did you do that problem? Remember, you had a problem like this. A load like that, something like that. Did you cut it here and cut it there? Yes or no? Yeah. You have to do that. Is that anytime load changes, you have to set up a new system. Yes, because the moment diagram, if the moment diagram goes like this, see, this function is different from that function, is going that's different from that function. Yes or no? Do you see what I'm talking about? This is all going back to a static and ME 218. That's why I don't have to repeat that, but apparently I should have made more emphasis on that. Everybody see what I'm talking about. Therefore, you have to cut this beam in how many times? No, let's see. A to B, B to C, C to D, and D to E. Is that correct or not? Actually, as a matter of fact, if this cuts here and then nothing there, 1, 2, 3, 4, and 5. Everybody understand what I'm saying? So let's leave it at that. Is that correct or not? So this becomes impractical. Why? Because I have to set up 4 setup system. Then I have to say theta 1 at x equal to something, whatever that number is, 2 meters or whatever I give you. Then theta 1 equal to theta 2. At this point, theta 2 equal to theta 3 here, theta 3. It's just not practical. Is that correct or not? So it is. That's why you never saw me giving you a homework in this set more than 2 loads. Is that correct or not? Yes? How do we get rid of that? That is a question we want to answer today. Hopefully we should be able to finish that. Look what happened. Now, let's assume regardless of the number here, I want you to draw shear and moment diagram for this system. Let's do it together. Don't look at the picture I have given you. If you have it, close it. I don't want you to see that. I don't want you to get influenced by that. Let's think about it, what we are supposed to do. This is all related. Let's draw the value is not important. So I'm going to draw a series of shear diagram. This is shear versus X. And here is point A and point B, point C, point D, and point E. What do you think the shear diagram looked when I started from that? First, what's the value of shear at that point? And epsilon to the right of A, what's the value of shear? You should answer me right away. Negative P1, yes or no? Because the load is going down, the shear is going up, therefore it is negative. Negative P1, so I go like this, and then continue all the way to E, because assuming nothing else is there, so that is minus P1, obviously. Yes or no? If there is no other load, correct? Then we reach to point B, suddenly another load is there. Everybody knows by now that if I have the P1 is 10 and P2 is 5, suddenly instead of 10, I get 15, correct or not? Let's see what happened as the result of second one. As the result of the second one, you draw that separately. That's why I want you to understand for today's lecture. This is a new lecture. So again, this is shear versus the X. Again, point A, B, C, D, E, etc. This time the shear starts at what? At point B. Is that correct or not? Yes? And the value of that is how much? You see, don't forget about that. That has nothing to do. That I already plotted all the way from beginning to the end. Now, assume there is a shear force there. What would be the shear force here? The shear force will be equal to P2, yes or no? Plus or minus? Minus. So I have to start here, minus P2, and go all the way to the E. Is that correct? That's constant, by the way. If it's going slope down, so ignore it. Constant P2. Is that correct or not? Yes? Then we go forward. We come to the M. M is not going to affect your shear. Is that correct or not? So has no effect there. Correct or not? Then we come to point D. Correct? For point D, if I want to draw the shear diagram, again, this is your shear versus X. This is point D. We already passed A, B, C. Now, how the shear diagram going to look like from that point on? Everybody should know that. It should be linear, correct or not? But it's plus or minus. That's the whole point. Minus, because the force is going down, the shear will be going up, and that system is negative. Is that correct or not? Yes. Therefore, that will give me this to the point E. So this is constant. This is constant. This is minus W, X minus what? X minus, let's put here some number. Let's say here is A, just for simplicity, A and A, let's say the whole beam is 8 meters long and A is 2 meters. Is that correct or not? Yes? X minus what? X minus, this is math. X minus 4 or 6. 4 or 6A, or 3A, I'm sorry. I said 2 meters, but it is 1, 2, and 3. So W, X minus 3A, yes or no? Is that correct or not? Yes? I hope you know that. Agree or not? Like I can see some of you, your eyebrows went together, so that means I didn't get it. So this is calculus, guys. This y equal to kx. This y equal to k x minus a, because this is a. You are starting from here. Is that correct or not? That's what I'm doing. Is that correct or not? Yes? Everybody knows that, so you should know that. Is that correct or not? But it is linear. That's why you see x, or minus wx minus 3a. I just write it better. Now let's do the same thing for the moment, guys. Okay, if I want to draw the moment, I need this board for the future lecture. So let's do the moment here or in this side. I hope you can see it from there. If I want to do the moment the same way, how many moment diagrams should I draw? Actually, this is combination of this one gives me the whole thing. Is that correct or not? Yes? The moment is the same way. Action of that, action of that, action of that, and action of that. Is that correct or not? But let's see whether we can do that by inspection. So again, this term M versus X. The points are there. Point A, B, C, D, and E. Is that correct? H1A. Is that correct or not? Where do you think the moment start here? First of all, is it plus or minus? Start at 0, yes. Then it was going to be constant or linear or what? Linear, yes or no? Is it going to be plus or minus? Minus, because the shear is minus, integral of the minus is minus. It's obvious. So you can look at it different way too. If none of them is helping you, the integral of negative will be negative. The integral of a constant is a linear. Everybody knows from AB to 18. Yes or no? This is all integration after all. Not even that. Look at action. The action is positive. The reaction is negative. And these are all about the reaction. Is that correct or not? This is internal. So therefore, this one will end something like that. So if you are at this point, will be equal to P times 4A. Is that correct or not? But it's negative minus P times 4A. Yes? Agreed? Correct? Based on what you know from integral. Now, for the second one, also will be the same thing. So this one is minus P1 x minus 0. Yes or no? Because it starts at 0. Correct? I'm making it routine. Yeah. So the second one, the effect of the second load is x versus m, but it starts at point B, not at point A. Yes or no? But still will be the same. Is that correct or not? Yes? Because that's also linear, because that's P2. Action is positive, reaction is negative, correct or not? And here is negative. Everything is indicated that. But this equation will not be P2 times x minus 0. Will be x minus A. Is that correct one? And then we go to the third one, which is this one. Remember that one. That's the one that usually when you do the integration, you are going to miss it. In this one, what do I get after? You see, before I come to point C, nothing. That's what I have there. After point C, therefore, suddenly your moment is going to go either up or down. We have seen that before, yes or no? Is it going down or is it going up? Down, correct. Very good. So therefore, the last one, notice everybody. Now, again, this is what's happening. This is the beam. At point C, you have, that's the MO action. You need this M, internal M. M internal, I'll put an I there. So these two together form that format. We have talked about it many times. And that format is negative. Therefore, the moment diagram should go down. Is that correct or not? Or if I plot it like that, and that plot will be, again, you can see it, but we are at point C. At point C, we have to go minus MO all the way to point E. Yes, sir, because it's constant, correct? Because forget about the rest. I cut it here, minus M minus A, as a, I'm not reaching to that one yet. Is that correct or not? Yes? Finally, we're hitting the last load. Is that correct or not? If I want to bring that into the system, then I have one more moment. Then let me draw that one. And that one, this is point C. So that one, this is point A. This is point B, C, D, E. And the last one, so you understand now what I'm saying, that this is M, this is A, this is B, this is C, this is D, and this is E. Start from here, and it will be a negative parabola. Yes or no? Correct or not? Because notice the integral of a linear is a parabola. Yes or no? And the integral of that is minus P2 x minus A to the power of 2 over 2. Yes or no? We have done that in the past. So that equation will be minus W, actually, because it starts at WO, which is that's the load given there. WO times x minus A to the power of 2, which you have seen it doing me. Now notice there is a pattern then here. That pattern is something happening, either step function we call it, remember from the math, or what?
Is it supposed to be x minus 3a?
What? X minus, yes. X minus, yep, thank you. X minus 3a, correct. If that's what you wanted to tell me, yes, that's correct. Because starting it at D, distance is 3a. Yes, sir. This one is 1a, that's correct. This is correct. This one doesn't have a because it's constant. Yes, sir. Good. So everybody understand what we are doing. Correct? Now this, I can now change the problem. Since there are all of them, I can express all of that at one equation. This is what the singularity function. Remember how much difficulty we have to cut it here, to cut it there, to cut it there, to cut it. Now we don't have to do it. This is the advantage of singularity method, which is the basis for computer programming as well. Everybody understands. How to write 1m represent all 4 sections. Everybody see what I'm telling you. We call those singularity functions. So please write it down. These are the singularity function. Singularity, and they are very important. Now, when you learn it, it is so easier to use that you may want to forget about the other method. Always use the singularity method because this is the simplest of all. Is that correct? Of course, to me, superposition is simpler, but for you as a student, maybe you find that a little bit more difficult. But quite frankly, superposition is the simplest. As we go forward, I make it simpler and simpler to get rid of all the problem you had with this homework. Everybody see what I'm telling you. This homework was purposely given to you to suffer. Everybody understands? Yes, to see the advantage of the new method, you have to go through this to see what is involved. If you don't know what's involved, so what's the purpose of giving something new to you? Everybody understand what I'm saying? That this is done purposely in this format for you to learn the process. Is that correct or not? So you see, to get to the point, I cannot use that method for this beam. Is that correct or not? Yes, there's too many sections. Correct? Now, here is the singularity function now. The first function is I write it in form of math, then I apply it here. This is x, this is y, this is the function. It goes like that, goes up. We call it a step function. You all have had this in the math. So this distance, this is 0, or O center of coordinate. This distance is a, and this height is c. So we write it like that. We say y. First of all, understand what this means. That means for x less than a, y must be equal to 0. Yes or no? For x larger or more equal to a, y must be equal to that. Y must be equal to c. Yes or no? Is that what I represented with this step function? Yes or no? Everywhere here from minus infinity to a, y is 0. Suddenly at this point to the infinity, again, y become equal to c. That's like a step. Yes or no? So therefore now, to represent that and computerize that, that's the whole idea for computerizing this. By the way, when I discussed that in one of my classes, 2 students got together and they wrote a program for one of these sophisticated beam with 5 span, and they were so happy that they could do it by computer. I'm not suggesting you should do that, but I'm saying that they were so interested in this system, they wrote their own computer program, which was very interesting to see what they did. Is that correct or not? Now, what happened here is this. You write this, y equal to c bracket. You write a bracket, not a parenthesis. X minus a to the power of 0. With the following understanding, you have to write the meaning of that. First of all, it's not parentheses, it is a bracket, as you write it in computer programming. If the value, write it down. If the value inside the bracket is negative, if the value, write it down. This is very important. You have to put it in the box. If the value under the bracket is negative, assume bracket equal to 0. Set bracket equal to 0. If the value inside the bracket is positive, change the bracket into parentheses. Act like a parenthesis. That's exactly if a statement does for you in the computer. If you put a if statement, conditional statement in your system, programming, some of you have done programming. Anybody have done programming before? Just so you know what I'm talking about, conditional statement. So good. If you put condition, if the value is negative, forget about it. Set it equal to 0. If the value is positive, act as if it is a parenthesis. Look what happened here. Let's say that a is equal to 3 feet, and C is equal to 10 kips. This is the load. Is that correct or not? Remember, it was P1 and P2. So if I am at minus 3 feet, what will be this value? Minus 3 feet and minus 3, that is minus 6. This value is negative, it's 0. Is that correct? So anywhere here, it will be 0. But if I go to plus 8, what's this value? 8 minus 3 is 5. 5 to the power of 0 is 1. So it becomes equal to C. Everybody, so this, as a computer representation, shows nothing here and this for the rest of it. Is that correct or not? This, because this is one of the singularity function. What in general we call it in the math, this step function. Yes or no? Then we go to the singularity function, the rest of it. The next one we need is what? So after the step function, what do I? These are the constant one. Look, I have a constant here, a constant there, a constant there. The next one I need would be a linear with the same format. Everybody understand? The next one is this one. So please write it down. This is math again. This is linear. I just put it positive, but we can assign sign to that. I need K. This K is the slope of the line. This distance is A. Again, writing it in this format, Y this time become K, X minus A to the power of this time what? To the power of 1, because it's linear. Is that correct? Yes? As I warned you before, I said it, when we get to the higher strength of material, everything become math. As you see, it is all math. Is that correct or not? Yes? And then next one, of course, will be what? Again, with the same value. If you are here, it becomes 0. If you are there, then it becomes a parenthesis. That's exactly what you want. Is that correct or not? The next one would be, of course, a parabola, obviously. This is the parabola. This is the slope of the parabola there. This time you can write it in this format, which we had it before, so I can just combine the two together. This time Y become equal to K, which in our case become W over L, multiplied by X minus A to the power of 2 over 2. That's the format we were using. Correct? Yes? Now, I can express all of that as that form. Is that correct or not? Yes? Now, let's do this. Practice this. Now, all the beam, whatever I give you, you write one equation for shear if you want to, and one equation for moment for entire beam. Yes or no? Okay, let's do this problem now. I'm going to give you a real problem. Now, this method, you establish for any one of them, one of these three. 1, 2, 3. We don't go beyond that. Is that correct or not? However, if you want to go beyond that, let me express it. The next one would be Y equal to K, X minus A to the power of N divided by factorial. If you keep that system that I show you, it is the computer system. Is that correct or not? But it has to remain like that. So 1, 2, 3. Actually, when I write it in N, covers all of them, including the step function. Is that correct or not? You can integrate that. I will show it to that next time because I don't have time. And you can take the derivative of that one. So it has become very simple. If I have the system, I can write it. Let's write the same one because I don't have time to do another problem. I'll do the problem next time. So let's say this is P1, this is P2, that is MO, and that is, if I want to write M, this is how I write it. That's M as a function of X. Look whether you agree with me. Minus P1, X minus 0 to the power of, what's the action of the moment? Look, the moment from here will be P times X, yes or no? Correct? So will be to the power of 1, correct? With me? Start at 0, yes or no? This is a linear function because remember I erased it, but the moment was, look, this one, yes or no? All I'm doing, changing the bracket into 1 because the moment, the shear is constant, so I have to use 0. The moment is to the power of 1, correct or not? Yes? Then when I get here, what should I do? Come on, you, give me the answer. Minus? First of all, the action is positive, the reaction is Negative minus P2 times what? X minus what? This was A for X minus A minus A to the power of 1. Then we come here. It was negative M. Yes or no? Yes? Remember, we just did it there a few minutes ago. There it is, sitting there. Minus M, you have to recognize that. Is that kind? Because you are past. That's what I was telling at the beginning of the class. When you cannot draw a moment diagram for a simple beam, how can you understand this? So that's my problem. Because that's a few of you who couldn't do there. I have a problem with that. Everybody see what I'm talking about. From now on, everything is here. I don't need to go to that basic thing because it is so obvious. This one, from then on, it gives me a constant moment, yes or no? That constant moment is negative because this is the action, the reaction is negative. Time what? X minus, where does it start? At 2a to the power of what? 0 because it's constant. Everybody see what I'm, and then we come here, this becomes minus WO because this is WO. X minus what? X minus 3a to the power of 2 over 2 factorial because it's a parabola. And then on and on. For a linear, you have to go x3 to the power of 6. This is the moment equation for entire beam. We use that to integrate and to do everything to use it for the determinant